Right, so let's do a little bit of an overview of what we're going to be going over today. First thing, our topic for today is 5.2, linear factors and zeros. This is part 2 of that. Our objective for today is to identify the zeros of a function, determine their multiplicity, find the relative maximum and minimum. So we've gone over how to find the zeros of a function. Went over that last time. Now we're adding on multiplicity to that. And we're also talking about maximum and minimum of our graphs. So those are the two new things that we're going to be going over. As usual, you will show this on the exit ticket, the quiz, and then the unit test. Which are main places to show it. A little overview of what we're going to be going over. We're going to do a review problem right up here of example 1. We're going to talk about it a little bit down below. And then we'll go over some definitions, and then we'll do some problems based on those definitions. What the steps involved, all that good stuff. At the very end, once we're done with explaining all that, you'll do this you-do problem, which has our objective-based problems that are we're going to show and everything. Boom. And then at the end of the day, you'll complete your exit ticket like usual. Okay. Start off, let's go back up to the top. I would like everybody, I'm going to give about 5 minutes, let's say, to complete this. I would like you to try and do your best at finding the polynomial function for this function for these zeros right here. All right, so 5 minutes to do that. A little helpful hint. I'll help you with the starting point. So I should always start with something like, just like below when I was making my functions down below, this is a way to do it. So I'm going to start with that. X equals -2, X equals -2, X equals 2, X equals 3. And then I'm going to go backwards from there. Equation. I'm going to move this over. So my first zero will be X plus 2 equals 0, comma space, X plus 2 equals 0, comma space, X minus 2 equals 0, comma space, X minus 3 equals 0. And then I'm going to put all those together. Actually, don't space that one. In parentheses, X plus 2 times X plus 2 times X minus 2 times X minus 3, all equals 0. And then you're going to simplify from there, using whatever method you want to use. All right, again, you have 5 minutes starting now to complete that. Try your best. If you get confused, you can always look at this problem down here, see how we did it, try and do it the same way. Good luck. Here for any questions. Sit here and wait. Got some good answers. Some people said the first two. That would be a good answer, going in order. It wouldn't be the best answer though. Anybody tell me what the best two to multiply together? Maybe why? What if I look down over here? What two did we multiply together first here, and what happened? What do you notice as we multiplied these two together? What happened to my final answer down here? Remember, you can put it in the chat or you can unmute yourself. Either one's okay. That's correct. The middle two terms canceled out. So my plus 2 and my minus 2 canceled out. And so if I pick two that are opposite signs, like this one and this one, to multiply together, then they're going to cancel out their middle terms. So it's called a difference of two squares. Let's put that. A little arrow. Difference of two squares. All right, so since these are difference right here, they have two different ones, I'm going to use my difference of two squares property to be able to multiply them real easy. First one stays the same. That says minus. Focus. when I multiply these two together, I'll end up with x squared minus 4. So the nice thing about multiplying two things together that have opposite signs. So I multiplied these two together first. All right. Right there. Ended up with x squared minus 4. And then left over is the x minus 3. Can anybody tell me what might be a good one to pick next? So remember, it doesn't actually matter which one we pick next, but which one should I pick next and why? There's a little tricky answer to this one. Anybody have a guess? You have a 50-50 chance, so. All right, I'll tell you the answer, then you tell me why. Why should I pick this one right here as my 2 to multiply together? Anybody tell me why? I like that answer. They're both negatives. That's not quite the reason. Anybody else give me another reason? A little cheeky answer why we should multiply these two together instead of some other pair? It might have something to do with this thing down here. Why might it be good to choose these two instead of the other two? I'm looking at this right here. Force out of you guys. Well, the cheeky answer is that I already did that math. I already have that answer. I already know what x squared minus 4 times x minus 3 is. So I already know that it's going to turn out to be this. So I can skip the actual work of actually multiplying these. I'm going to skip to right saying x plus 2. That's not a plus. Times x cubed minus 3x squared minus 4x plus 12. And again, I got that from down here. We had done that math yesterday in one of our problems. So we already know what that answer is. We already know what that FOIL works. All right, let me get this. Now we'll FOIL out this last part. Show that FOIL. Start with my first two terms. First two terms. Second two. First and third. First and fourth. And I do all the other ones down below. 1, 2, 3, 4. Can anybody tell me what my final answer should be? What should I get for my first term in this case? Anybody tell me. X to the fourth, good. Great first step, x to the fourth. What's my next term? Good, minus 3x cubed. Next one. And this is where you can branch off a little bit, maybe think about something a little bit differently. I like that answer though. But close, that's not quite right. Go minus 4x squared. And finally plus 12x. And then I go back and do all the ones underneath. 2 times x cubed gives me a plus 2x cubed minus 6x squared Make sure I'm doing all the math right. Minus 8x plus 24. A good check to do is to see that there's as many numbers down here as there are little strings that are connected. So there's 8 strings total. So we have 1, 2, 3, 4, 5, 6, 7, 8. We have all of our multiplications accounted for. So now we just have to combine our like terms, and that'll be our final answer. So x to the 4th is our first term. That's the one, only one. I have x cubed and x cubed right here. So I get minus x cubed. Negative 4 minus 6 gives me a negative 10x squared. 12 and negative 8 gives me a positive 4x. And then finally, plus 24 equals 0. I also forgot my equals 0 at the bottom here, so I'm going to add that here. So that's my final answer. Are there any questions about that process? Questions about the process? All right. Then real quick, I'm going to give you some open-ended time right here. I would like you to compare that process that we just did, going through this problem, with the process we did for example 3 right here. Oops, typo, that should say 3 right here. Compare that to the process here, and I want you to talk about how they are different. What's different about this problem? What's different about this problem? Some things to focus on, some topics you can focus on. Degree. It's a great one to talk about. Number of terms. Process. How we actually multiplied them together. Or anything else you might think of. All right, I'm going to give you about 2 minutes to do that. Put your answers down here. You have 2 minutes. Talk about whatever you want, and then we'll go over a couple of them. All right. 2 minutes starting now. Completing this question. Again, you're comparing it to this right here. I'll leave as much as I can up on the board between the two, so you can actually see part of it, but there's no way I can show it all, so. As long as you wrote something down. So let's move on to our definitions. We have 2 different definitions for today, multiplicities and relative maximum and minimums. The multiplicities has a very strong definition right here where it's talking about if A is a 0 of multiplicity n in the polynomial, then all this relates. What we're really going to talk about multiplicities is it just means how many of a 0 are in the answer. All right. So like up here, for this problem right here, we had 2 negative 2's. So this right here would have multiplicity 2 for negative 2. So if I was writing out that answer, I would say negative 2 is a 0 with multiplicity 2, because there's 2 of them in the answer. And then for the other 2, since they are just singles, I'd say 2 and 3 are zeros with multiplicity 1. All right, that's what really multiplicity means. It's just I'm counting how many times they happen in my answer, in my number of zeros, and then I'll put that number as my multiplicity. It's that simple, all right? Negative 2 happens twice, so we put 2. 2 and 3 happen once, so we put 1, right? Since all 3 of these answers right here only happen once, I would say that they have multiplicity 1. They only each happen once. Right? Are there any questions about that? Let's change that up. What questions do you have? Remember, I can't know what you're thinking unless you tell me. Let's move on for now into the other part. So again, that's a perfect question. Someone said, I don't understand how to determine the multiplicities. I determine the multiplicities by looking at the zeros, right? So I have these 4 as my zeros. Then I just count up how many of each thing I have. So that I had 2 negative 2s. So negative 2 is a 0 with multiplicity 2, because there's 2 of them. On the other hand, 2 and 3 were zeros for my problem, but they only had multiplicity 1, because there's only 1 of them each. All right. For this problem right here, each one of these things only happened once, so we have multiplicity 1. Right. So it's just counting up how many times they happen, putting that number down. Now there's some special things that connect to the graph of our function with multiplicities. If the multiplicity is odd, the graph passes through the 0. So let's say this is my x-axis right here, coming through this way. If my multiplicity is odd, then my graph's going to come down through it, not stop at it. If my multiplicity is even, so like 2 or 4 or 6 or any of those numbers, it's going to come down and touch the graph, come back up. It's not going to pass through it. It's going to stop right at it and come back up. Okay? That's what multiplicity happens on the graph. That's how it changes the graph. So if we look at Desmos and we look at our graph, which is, which function is this one? X squared minus x cubed. If we look at our graph, we have 3 different zeros. This one, and this one. When we had multiplicity 1 for the 2 and 3, they passed through the x-axis. On the other hand, since we had multiplicity 2 for negative 2, it touches the graph, comes back up. We have our turning point right there. So that's how they connect to the graph. If it has some odd number of terms, odd number of zeros, then it stops at the graph. If it doesn't, then it passes through the graph. Are there any questions about that? How the graph and the number of zeros connect? Again, only know if you tell me. Let's do a quick example, see if everybody can see it. Give you a little bit more of a concrete example. So let's go with something like x minus 1. Let's see if x minus 1 had a power of 3. Since it's an odd power like this, I have multiplicity 3 right here. Since 3 is odd, we have multiplicity 3, so it continues through it. All right, it goes up and through. It doesn't stop here. It doesn't stop and come back up. But if I change that to multiplicity 4, now it comes and stops at it. So if we look a little bit closer, stops right at that point and comes back up. Right, and that's what it means. If it's an even number of power, there's an even number of them, then it comes back up. If there's an odd number, like let's change it to now 5, it's going to go through again. Right, that's all it really means, how it connects multiplicity and graph. Odd number goes through, even number goes back. A good way to check that with our factored form is that I can rewrite this function right here as, rewrite this right here, over here, one term, as x plus 2 quantity squared. Got my new equation. X plus 2 quantity squared times x minus 2 times x minus 3. So when I rewrite it like this, it's much easier to see the squared part, how they're going to be two terms. There's going to be one of these and one of these. So when I rewrite it like this with the factored form this way, it's a little bit easier to see. This one will stop here, go through and go through. Are there any questions about that? All right, what's your question? So again, all I did to go from here, this answer right here, to this answer right here, is I just combined these x plus 2's. Since I had two of them, I made it squared. That's all I did. I think it makes it look a little bit nicer and a little bit easier to understand. But whenever I have a squared like this, it means we have two of them. I have a single one, so I have one. So this is something new. So this relating to the graph thing is how the solutions, how the number of solutions change to my graph. Right? And so these are different ways to talk about that solution. So let's go down to our problem for multiplicity. We'll talk about this one right here. Right? So this is more of the problem that you will see. That'll ask you for multiplicity. They'll be given some function, usually something like this. Then you'll have to factor it first. Once you have it in factored form, I would tell you to rewrite it as x minus 2 quantity squared times x plus 2. Right? So I combine my like ones, leave my different ones alone. All right. Now tell me how many zeros I have. So x minus 2 are both zeros. So I have two 2's and a negative 2. So I have my zeros. All right. We've gone over how to do this last class. So this shouldn't look too unfamiliar to you. It should be pretty understandable. This is the new section down here. All right, so don't get bogged down too much with this stuff up here. We can have plenty of time to go over that stuff. For now, the new stuff is when I have my zeros, have my answer like this, I can take those zeros and I can talk about them with multiplicity. So before this would be our final answer, now we're adding on another step of talking about them with their multiplicity. So since I have two 2's, I'm going to say it has multiplicity 2. Since there's only one negative 2, I say multiplicity 1. Right? Now, I'd also like to note that this up here is not your final answer. All right, this is extra work that we're just talking about with the definitions. The answer to this problem would be this answer right here. This is extra, just talking about our definitions as an example. All right. Seems like that was confusing some people. This right here is extra, not actually part of the problem. This would be your final answer for your problem. This was talking about multiplicities and everything. All right. Does that answer some of y'all's questions? Does anybody have any other questions I can help you with? So again, this is just another way to talk about our solutions. We're adding more vocab so we can talk about how that changes it. And then we can talk about how that affects our graph. So we're connecting all of our different topics in math so we have a robust way of talking about it. Does anybody have any question that they want to restate or anything? All right. So we have this answer right here. The other topic we're going to talk about is relative maximum and minimums. This is another part of our graph. All right. Maximum. Okay, let's go back to it then. So do you not understand how we write this out, like how we get this answer, or why we get this answer? All right, so how we get our answer is we have our 3 zeros. All right, these are the zeros from this function. We did that by factoring, and then setting each factor equal to 0, and then solving. Right? From there, we take our number of solutions, and we find out how many of each number we have. So we have 2 2s. So we have 2 as a 0 with multiplicity 2. So there's 2 of them. We only have 1 negative 2. So negative 2 is a 0 with multiplicity 1, which just really means that we have 1 of them. Right? Multiplicity 2 really just means 2 of them. Multiplicity 1 just means 1 of them. So really that's what we're just talking about. We're just taking it one step further from our answer that we got last time of my zeros are some numbers. And now we're adding on this multiplicity part where we're talking about that, how many of each number there are. All right. Does that answer your question? Again, I just count up however many I have. So I had 2 2s, so I have 2 with multiplicity 2. I had 1 negative 2, so I have negative 2 with multiplicity 1. Anybody else with a question? These are great questions. Then for now, we're going to go on to relative maximum minimum, and we'll come back to it. Relative maximum minimum are just talking about where we turn from up to down or down to up. It's really just talking about, we're looking at our graphs. We're talking about the different, other way, let's do that for some reason. The different grooves, either the valleys or the mountains. When it's a mountaintop, it's a maximum. When it's a valley, it's a minimum. So up here is a maximum because of the fact that they're going from left to right, up to down. All right? This is a minimum because it's a low point. So it's the lowest point, max and min. To find these, we're going to use Desmos every time for this class. All right? You're going to plug your function into Desmos, like so. Plug it in, and then you're going to find out your low points and your high points. Nice thing about Desmos is if you click on your graph, they have those points for you. And so you can just click on them and you can find out exactly where they are. All right. So I have these 3 points. So for my first answer from that first problem, another way to talk about the graph, another way to talk about the function would be its maximum and minimum points. That answer has 2 minimums and 1 maximum, and they're at these 3 points. Right. So again, this is just more vocab to be able to talk about our graphs, how they connect to our function. Right. If we're looking down here at our problem right here, for this one, this answer right here, sorry, this one right here, we can see that we have 2 maximum minimums. Do something real quick though. Get rid of this. There we go. Should move it up. That should allow me to actually see my graph. Perfect. So my maximum, this graph right here, only has 1 maximum. Right? And it only has 1 minimum down here. Shrink my graph, shrink my thing a little bit so we can actually see it. There we go. So my maximum is at that point right there. So I'm going to put that. My maximum is at -3.361, comma space 30.745. My minimum, on the other hand, all the way at the bottom, so I'm going to scroll down at 0.694, comma space -2.597. Notice that I put them as a point and not as just an X value or a Y value. It is a point on the graph. It is not the tallest point or the smallest value. It is that point. Right? So I expect you to use ordered pairs for all your answers. Now what you'll find mostly is that degree and the number of maximum and minimum are kind of connected. For the most part, when you have degree 3, you will have a maximum and a minimum. For the most part, there's some special examples where you won't have that, but for the most part, when you have degree 3, you'll have a maximum and you'll have a minimum. If you have something else, like degree 4, like we had at the top, right here, we had a degree 4, we can see that we have 2 mins and 1 max. So we have 1 less than what we had. All right, so now we have 3 right here. That's kind of a connection that we can kind of make between a lot of these. The number of mountains and hills should be pretty close to that number right there. 1 less than your degree usually. Are there any questions on finding maximum and minimum? Again, just a reminder, we plug it into our graphing calculator. I like to use Desmos. If you have something else you like to use, then you can use that. And then you graph it. Once it's graphed, then you just look for your top points and your low points. Any questions about finding maximum and minimums? Any questions in general about today's lessons? Anything you want to go over again before we start the UDO problems below? So if you feel like you're pretty solid on this and you want to skip any more of my explanation, then you can start the UDO problems down below. I left the factored form down here. So if you want to move on to, after that, finding the zeros and then doing all that work, that's fine. And then number 2 has the finding the same graphs, right? So I've already started the problem for you. You guys can work on that. If you have any more questions, I'll answer them. Someone said, how do I find the degree part again? So again, the degree is just my highest exponent. So my biggest exponent is x cubed. So my degree is 3. For the most part, so for a couple of specific things, my number of maximum minimums will be 1 less than the degree. All right, so my degree is 3, so my maximum minimum will be 2 of them. It's like we see here. The one above, we saw a degree 4 polynomial, because their highest term is an x to the 4th. And so we saw 3 total maximum and minimum. All right, 1, 2, 3. If we saw an x to the 5th one like this one, we would see 1, 2, 3, 4 different ones. One of them's way down here. All right. Are there any questions about this topic at all? Any other questions? All right, then start on the you do section. Let me know when you're done. Let me know if you have any questions I can help you with.